In electronics, a common base amplifier is one of three basic single-stage bipolar junction transistor amplifier topologies, typically used as a current buffer or voltage amplifier. In this circuit, the emitter terminal of the transistor serves as the input, the collector the output, and the base is connected to ground, or common, hence its name. The analogous field effect transistor circuit is the common gate amplifier. As current is sunk from the emitter, this provides potential difference, so causing the transistor to conduct. The current conducted via the collector is proportional to the voltage across the base-emitter junction, accounting for the bias, as with other configurations. Therefore, if no current is sunk at the emitter, the transistor does not conduct. This arrangement is not very common in low-frequency discrete circuits, where it is usually employed for amplifiers that require an unusually low input impedance, for example to act as a preamplifier for moving-coil microphones. However, it is popular in integrated circuits and in high-frequency amplifiers, for example for VHF and UHF, because its input capacitance does not suffer from the Miller effect, which degrades the bandwidth of the common emitter configuration, and because of the relatively high isolation between the input and output. This high isolation means that there is little feedback from the output back to the input, leading to high stability. This configuration is also useful as a current buffer since it has a current gain of approximately unity. Often a common base is used in this manner, preceded by a common emitter stage. The combination of these two form the cascade configuration, which possesses several of the benefits of each configuration, such as high input impedance and isolation. At low frequencies, and under small signal conditions, the circuit in Figure 1 can be represented by that in Figure 2, where the hybrid pi model for the BJT has been employed. The input signal is represented by a THA copyright Venin voltage source, versus, with a series resistance Rs, and the load is a resistor RL. This circuit can be used to derive the following characteristics of the common base amplifier. In general, the overall voltage/current gain may be substantially less than the open/short circuit gains listed above due to the loading effect. For voltage amplification, the range of allowed output voltage swing in this amplifier is tied to voltage gain when a resistor load RC is employed, as in Figure 1. That is, large voltage gain requires large RC, and that in turn implies a large DC voltage drop across RC. For a given supply voltage, the larger this drop, the smaller the transistor VCB, and the less output swing is allowed before saturation of the transistor occurs, with resultant distortion of the output signal. To avoid this situation, an active load can be used, for example, a current mirror. If this choice is made, the value of RC in the table above is replaced by the small signal output resistance of the active load, which is generally at least as large as the rho of the active transistor in Figure 1. On the other hand, the DC voltage drop across the active load is a fixed low value, much less than the DC voltage drop incurred for comparable gain using a resistor RC. That is, an active load imposes less restriction on the output voltage swing. Notice that active load or not, large AC gain still is coupled to large AC output resistance, which leads to poor voltage division at the output, except for large loads RL route. For use as a current buffer, gain is not affected by RC, but output resistances. Because of the current division at the output, it is desirable to have an output resistance for the buffer much larger than the load RL being driven, so large signal currents can be delivered to a load. If resistor RC is used, as in Figure 1, a large output resistance is coupled to a large RC, again limiting the signal swing at the output. An active load provides high AC output resistance with much less serious impact upon the amplitude of output signal swing.